Welcome to Theory of Computation class. So in this class, we should know about the concept behind language. Previous session class contains alphabet and string operations. So we are aware that alphabet is a collection of symbols which are all used for framing string. String means the definition of string is a collection of words which have some meaning in it, and few operations can be performed on string. Here the third concept of automata theory is a language. So a language is described with the notation or a symbol called L. So here we are aware that sigma star is a clean closure. So you know about sigma star is equal to sigma power 0 union sigma power 1 union sigma power 2 union dot 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 sigma power n. So which is also called as clean closure. So you know about it. So L is nothing but a collection of L is a language which contains a set of strings from 0 length, 1 length, 2 length strings to infinite length string. So any set of string over an alphabet is called a language. So here, how can you able to form a language for the given notations? For example, here they will give the alphabet letters sigma is equal to A and B. So how to frame a language? Language means L is equal to sigma star. So it contains some restrictions in it. So what restrictions? This language should have a set of string starts with a symbol A. Here they are already given alphabet value sigma is equal to AB. If there is no restriction for this string means L can be denoted as L is equal to there are empty string, so epsilon is possible, single length means AB is possible, two letter means AA, AB, BA, BB is possible. Like that the set of strings will be framed. But the condition behind this languages all set of strings should start with A. So there is no possibility of B. There is no possibility of epsilon. There is no possibility of BA, BB. So all strings should have the first letter as A. So this should be first letter A. If 2 length means the first letter should be A. If 3 length means the first letter should be A. So this is the way of framing language. Second example for a language construction. Here they are not giving an alphabet set, but they give the conditions with the symbols AB. So we assume that the alphabet set is sigma is equal to AB. So what is the conditions? A string contains equal number of A and B. So how can you frame it? For example, all this string contains A and B. So equal length. If the length is 0, there is a possibility of epsilon. And there is no way of framing a single length string. Because A should be available means the same B letter should be available. So there is no possibility of odd length string. Only the possibility is even length string. So A will be available means equal length. A single time means B should also be single time. Then 2 letter means if you are using double A, 2A, you should use 2B. But the formation will be differed. It may be AB, AB. Or it may be BA, AB. Or there may be the possibility of BA, BA. Or there may be the possibility of double B, double A. Are you aware of this? So in this way, we can able to frame a language based upon some conditions in it. So for example, here just a minute. So describe a language. Describe a language which contains all strings with exactly 1A at end. So they are giving sigma is equal to AB. The condition for framing a set of language L is equal to all strings should contain a letter at the end. So there is no possibility of epsilon. So one length means only A is possible. Two length means BA. Or it may be A. Exactly 1A means there is no possibility of AA. So only 1A is possible. So AA, BA, BBA, triple BA, 4BA, like that the strings are framed. So this is a language L. This is the language L. So in this set of strings, we can able to write it as a generalized form. So L is equal to B power N followed by A, where N value may be greater than or equal to 0. So this is the generalized way of writing a language. So in these three examples, we are able to aware that a language can be described with the set of strings, or it may able to write it as a generalized notations. So these are all the language notations available in theory of computation part. So all symbols should be represented with a set. So if a language has an empty string, that is there is no strings in a particular set, means it is denoted as pi. So this symbol is denoted as pi. Pi means empty set. That means a set which does not contain one string in it. There is no strings in a set. So there is a difference between epsilon and pi. Epsilon is denoted for string. Pi is denoted for language. This is the first difference. Second difference means epsilon means empty string. Pi means there is no string in a set. So it is an empty set. So this is the difference between epsilon and pi. And sigma star is also denoted for a language L. We may able to perform these following operations on language. So these operations are also performed in a set. So you are aware that these are all the sets. Union, intersection, these are also available. Closures means clean closure, positive closure. Clean closure is denoted with sigma star. Positive closure is denoted as sigma plus. We are aware that sigma star is equal to sigma 0 union sigma plus. This is the relationship between these two closures. Reverse is also possible. These are all the operations which can be performed in language. Thank you.